the Soul Ranger, Soul Searcher, whatever that little
Hey,
device is.
we'll have to
Sun
continue this
spotter.
conversation on the program there, Chuck. Well, hello, everybody. Welcome aboard. We're doing it
The
again.
Soul Ranger, Soul Searcher, whatever that
That's right. We'll talk about soul searching,
device
soul
is.
reading. I have no idea what
Sun
these guys are
spotter.
on. They're on some sort of drugs. We're under marine layers again. May Gray. It is Monday, May 20th through the 26th next Sunday. This will be episode number 169 of the Santa Barbara Astronomical Unit's weekly vlog podcast, Monday mornings on YouTube, the SBAU Astro Hour. Welcome aboard. It's a deep, dark look into the heavens of Carl Sagan from our little blue dot here, starring the Big Bad Brain Trust of Santa Barbara, California's longtime telescope and astronomy club, the Santa Barbara Astronomical Unit. I'm your host, the proud man, Ron Heron, who used to do this on the radio. We decided to do it more and see ourselves instead of just hearing us. I'm the guy who's going to learn along with the rest of you. We're based at the Santa Barbara Museum of Natural History, a beautiful place up in the woods of Mission Canyon. And it's all there on SBAU.org. Love to have you join us. We'll talk about that. It is Monday morning. Here's what we're going to talk about today. Thursday morning, it'll be a full moon called the flower moon. Carl Sagan said this: we are star stuff. And we're going to talk about what the heck is star stuff. A big look at the interstellar medium this week, folks. We're going to talk star classifications. I counted 10 on Jerry's talking points, 10 different types, and women were involved in finding these. This week, the track of the number 1 and number 2 asteroids, one of them out there in the belt is a dwarf planet. We're going to show you where Comet 13P Olbers is in the night sky. Visit a double star, not a binary, but a double. And we're going to watch a 20-second video of rotating sunspots that produced those incredible southerly, well, something more southerly than normal auroras. And they're not quite as down. I guess Maine is watching them. Also, over the weekend, maybe you heard this. I learned this from the Times. What they're calling a breaking up comet caused a bunch of night flashes, some incredible bright meteors over the Iberian Peninsula. That's Spain and Portugal. Might be the subject of a future show. Let's meet the gang, shall we? Our president is Jerry Wilson. There he is on my left.
Good morning.
A veteran engineer marvel out at the great research and development spots along Hollister Avenue. And he's been in office here 7 or 8 years. I'm VP, and on my right is an incredible outreach, probably the best in America, Chuck McPartland, along with his wife, Pat. Incidentally, they're both married to Pat. Pat Forgy is married to Jerry, our president. She's one of my biggest supporters on our speakers, which is part of my duties. Chuck is married to Pat, and I'm going to call them the heart and soul of the club, everybody. She's the heart, he's the soul. Oh, no, she's the never mind. The head is on my left. That would be Jerry.
Nice there.
Yeah, let's meet the rest of the guys. Here they are. I'm not sure when you signed in, but Bruce Murdoch, a longtime supporter, telescope enthusiast, also president of the Santa Barbara Theater Organ Society. He's married to Bonnie. We have Tom Whittemore.
Morning.
Baking bread in his oven these days instead
of peeling beets today.
Say again?
Peeling beets today. I
peeling beet. You do a beet bread?
No, borscht. I'm Polish.
Borscht. I had borscht one time. I had a Russian woman move in with me for a month. She made me the purple soup. Anyway, we're all looking forward to our sourdough in the fall there, Tom Whittemore, former college professor at Westmont, where we do a lot of outreach. He's married to Maureen. And there is Tim Crawford,
howdy doody,
lens and telescope expert, who's married to Karen, and is kind of a loose cannon like myself at times. But gentlemen, I got to tell you, I probably did they get anything from that influx over Spain and over the weekend? Did you hear about that?
I did read about that. Yes.
Is it possible it could have been a breaking up comet? How in the world didn't we get that one?
It's possible.
Okay. Here's what we're going to talk. Oh, we talked about the headlines. Let's go to the sillies first, because our president likes to send us silly science cartoons, and Here they are, starting with this one called Bitter. It's a series of 8
I like
pictures.
this one. Yeah.
Yeah, on the left is what's happening. Blow it up a little bit. Look at everyone and everywhere. It's a full lunar eclipse, like April 8th. But on the right is what we got here, thanks to May Gray.
Yeah.
And then down the second one, gee, look, everybody, it's a newer, never before seen comet. Of course, we can't see it due to the cloud cover. And the third one, wow, look at that, man. A once in a 1,000-year planetary alignment. Yeah, forget it. And then the bottom is we don't get those auroras either. Or would we have gotten them if we didn't have cloud cover?
Oh, there were some that were visible.
Yeah.
People went up on the mountain crest and got out from the May Gray.
Okay, well,
I think
guess
they're
we're gonna
expecting
talk about
another
it.
CME in a few days.
Yeah.
I think they're abating, right? That surge
Yeah.
from the sun is going away.
That big spot rotated around. It'll be back in about 30 days, but there was
Yeah.
another one that was coming around the other limb of the sun.
Yeah.
So we'll
Sun's
see.
very active right now.
Okay, well, you're going to show us that 20-second video, I assume. Here we
Yeah.
go. This one is called Books We Want Banned. Teacher picking up a literary list from the anti-woke right-winger at the table. Turns it into a classroom fodder for her
See, that
own
used
kids.
to, when I was a kid, that used to be the hallmark of a New York Times bestseller list book. If the Catholic Church banned it, I mean, the sales just roared right up. That's what made Peyton Place a best book.
To Kill a Mockingbird comes and goes, doesn't it?
Yeah.
Yeah.
Here's a leaked NASA photo, wondering about the sun and how it goes away at night. Some kids might want to learn this. It's a leaked shot of a NASA truck, except we don't see the sun in this.
Yes,
Right
it is.
there.
It's in
There.
it's in
It's
the
in
half
the-
of it. It's in the barrel and the.
Oh, there it is. Okay, the angle of my screen kind of obliterated or made it all white.
Oh,
Somebody got a good vantage point. Hey, ladies, look at this. This would be, take my number, please.
Yeah.
Something about
Avogadro.
6.02 times 10 to the 23rd power. You want to explain that, Mr. President?
Avogadro's number.
Right.
yeah. That's
6.023
Avogadro.
is what I remember.
I forget his first name.
Is that
Oh.
astronomical?
Alessandro.
Okay,
Okay.
but he's got
Yeah,
some
this is the
takers. He's going
number-
to have some hot dates, apparently. I forgot all about that. You can cut those up and tear them off.
That's common on college campuses.
Yeah,
If,
you're right.
on a bulletin board. This
All right,
is
continue to get us in a good mood. Silly stuff.
6.02 times 10 to the 23rd. That's the number of atoms there are in 1 gram molecular weight of any substance.
Or the number
Mole.
of things in a mole.
Right.
Really? Even in
Mhm.
lead,
Oh.
which is heavier than hell?
Yeah, that's gram molecular weight. It's a smaller cube.
That's true. Gram is a gram. You're right. So,
Right.
okay. And here is the astronaut getting down off the moon. And he's stepping into some alien dog poop while the aliens behind the moon rock giggle themselves silly. That happened. They brought that back, didn't they? Here's genome research. A scientist in his lab gets the troubling correction from the Home Office that says, there was a typo in our previous email. Sorry, it should have, of course, read, please focus completely on genome, not gnomes, for crying out loud. Gnomes everywhere.
There was another cartoon that I saw probably 50 years ago that showed this laboratory, and it had little clowns running all over the laboratory. Little cars they're getting out of, they're doing all the clown things. And the director of the lab is chastising the scientist, and he says, yeah, I said I said clones, not clowns.
Yeah, yeah.
Oh, well, English is being, this one I kind of like. Interesting. You've seen this in all the swashbuckler movies. This would be the split arrows. The two archers competing. And I think I saw Errol Flynn do this in one Robin Hood movie or something. He actually split an arrow that was already in the middle of the target. And he says, beat that. And sure enough, he takes his arrow, the second archer, and splits the atom. Guess what happens in the bottom? That's what happens when you split an atom. And here we got, what did I write about this? Is this the bitter one? No, no, this is Well, it's a guy
Trading brains.
trading brains. That's where an exchange of brain from a microchip between a naked human and a cyborg android robot.
By the way, the first, if you didn't read about it, the first implant under Elon Musk's chip in a brain.
Neuralink.
What's that?
Neuralink.
The recipient's brain rejected all those platinum wire connections.
Yeah.
So it
Wow.
was a failure.
It worked for a while.
Yeah.
And somebody received a pig's liver or something, and they just died, I think.
That was a genetically engineered pig's kidney, I think.
Yeah.
It was a kidney from a pig?
Eventually they will succeed.
Yeah.
I've heard they're pretty intelligent, those pigs. And what do? We eat them, turn them into bacon and ham. Well, it should be an interesting week. Can't wait to see the 20-second video you came up with. That's off Facebook, isn't it?
In the Burke Animal Farm, the pigs became the leader.
Yeah, they were a little more equal than everybody else.
Right.
Oh, okay. Got it. Well,
just
shall
a
we look at the
moment
night
while I
sky.
manipulate things here. Oh, there.
Captain Kirk is our president, Jerry Wilson, who's in charge of the space. The oldest black astronaut who never went up got a ride on board. Jeff Bezos?
Blue Origin.
Oh, is that Branson?
No, it's Bezos.
Oh, is it Bezos? Branson had something else. Okay, what do we got here?
Video of sunspots.
Oh, there it is. Look at this. And it's
It's an
skirting around the
enormous
sun.
collection.
Wow.
Whoa, that's huge.
This is the sunspot group that gave us our CME about a week ago or 2 weeks ago.
Our
week
light
ago.
show.
Now I had I have the bad habit of leaving my computers on. I just walk away and they put themselves to sleep. And I had two computers that were on that Friday night. And when I went back the next day, I couldn't get them on. And then I found out that the surge protectors had blown. So they all had reset buttons. So I reset them and everything was fine.
Wow.
But it scared me for a moment.
I
Wow.
think I asked this
close.
last week. Is Southern Hemisphere, Australia, getting a similar display that's brighter?
Yes.
They are, okay.
Yes, our nephew down in New Zealand got them way up by Christchurch.
Now you see these things come in pairs mostly. Magnetic field lines come out of the surface, loop over, and go back in somewhere else. You can't tell exactly where it is because you can't see the lines.
But what's the 11-year cycle about? They flare badly and then they go to nothing over 22 years?
Well, the sun reverses its magnetic field every 11 years.
Is that what it is?
Yeah.
Yeah.
And that declines or makes more or less sunspots?
No, it's like a ball of twine. It has differential rotation. It's twisting up the magnetic field lines in there. And pretty soon they get so twisted, they pop and reconnect. And that's when you get these coronal mass ejections. That's a lot of energy released. And then they realign and they start out being benign again. And it takes about, 6.5 years to crank back up.
Well, the Earth is
11 years to crank back up.
the Earth is supposed to switch too before long or sometime.
We're sort of in the
the North
process
Pole
of
has
it
been
now.
moving. It's over Greenland now, a magnetic North Pole.
Is over what? Greenland? You're kidding.
The Earth's magnetic field is a vector sum of all the local magnetic fields.
Okay,
It's
but
caused by the magma in the Earth's
coughing
core or mantle rotating, which is a moving charge, which creates magnetism.
But it's not one thing rotating. It's a lot of little subcells that rotate.
Oh, yeah, right.
So what we
Yes.
see on the surface of the Earth is the vector sum of that. And some areas of the Earth, the magnetic north and south have reversed. And some of them are very low. So it's a gradual process geologically, or I guess it's instantaneous geologically, but on the human scale, it's a very slow, gradual process. It's not that our field completely turns off. There was a period about 100 million years ago, or maybe less.
That's about the length of the cycle is approximately 100 million years. So
that the Earth had a very low, the vector sum of everything was very low. And we had a lot of mutations and a lot of activity in the evolutionary arena, according to.
But north is going to become south, and those are not plus and minus or positive and negative. They're just directions, I guess, right?
Yeah, it's a goes into and it goes out of.
And is that happening on the sun as well when it flips every 22 years
Yes.
or
Yes.
11 years?
Well,
goes
it
through a
comes back
maiden
to the
in 11
original
years.
orientation after 22 years, but to us,
Yeah.
it looks like an 11-year cycle because the activity goes up and down over 11-year cycle.
And,
Right.
and Chuck, don't they travel, like, say, from a Tropic of Cancer, Tropic of Capricorn towards the equator and then back out again?
Yeah, they begin at different latitudes and then gradually change until they reach the middle, and then it quiets down again. And you'll see what's called a butterfly diagram of an 11-year cycle.
Yeah.
Okay, we're looking
Wow.
at it, right? This
So
is what
this is
causes
what
it?
happens when the sun throws a lot. You can see this, right?
Yes.
Yeah.
Yes.
Okay. So the sun throws out a lot of ions, particulate radiation. It is redirected according to the Earth's magnetic field, and it comes in at the poles.
Oh,
Now, it doesn't travel really straight like this. The ionized things actually spin around it in a real tight little helix pattern, but they still, this is their direction of travel. So this is what's happening.
That's how they do it, huh?
Whoops. Sorry.
that size matters up there. If you didn't read the small print. Okay. And many of the planets have this same thing going for them as long as they have a magnetic field. Jupiter, of course, has a huge one,
Yes.
but they don't get as much solar wind out there by the time it goes, what, 15, 20 more AUs from us? Does anybody know what I'm talking about? Obviously, the further out, here we go, to the sky.
Okay, we saw this again last week. This is the path of Comet Olbers. You'll see Olbers is more famous for things besides just this comet. But this is the start of, down here is January 16, 2024. And then as the year progresses, we go up through February, March, April, and here we are in May. There's May 25. So right there where the cursor is, and you see that's right in the middle of the Milky Way here. That's where the comet Olbers is right now. This is a particularly rich region of the sky. There's all sorts of clusters of nebula in here. It's traveling through Auriga. That's what AUR means here. So it will continue up in this path. From the Earth, it'll appear to go faster and faster because you can see the space is increasing between these dates.
So it's going right
this
to left,
is getting
uphill.
This is getting low in the west. You got to get there quick to see it.
Okay, what's the status of Pons Brooks, the earlier comet we were watching? Is it still up there?
No, that's gone in the southern hemisphere.
Okay. Oh, okay, gotcha.
So this is a close-up path for May. Here we are on May 20. Quite a lot of structure up here.
Oh, yeah, that's Auriga. Yeah, 30,
Yeah.
36, 37, 38.
IC 410 right there, a nice open cluster. And IC 405, which I think I have a picture of here. Oh,
I'm
no,
sorry.
this is the,
I'm sorry, what's IC stand for?
Index catalog.
It is,
Oh,
yeah.
okay.
Yeah, and that's a nebula.
Yeah.
So this
Okay.
is Auriga, and about, did I have the time down here? No. Got to go back.
Pretty early.
Yeah, this is like an hour before or right after sunset. So you got to be very quick.
Mhm.
And so this is the region right down here that you'd be looking.
Mhm.
This is, I believe that's IC 405 down here. So this is the comet is going up through here.
Looks
Now
like a
this,
diamond.
this is, oh, Pat's home. The cat ran out. So this is up in Hercules. Excuse me just a second.
So this is the summer stuff starting to come up.
Yes.
Oh, one of my favorite targets. M13.
Yeah, that and M3 are very nice. Ron, I didn't want you to feel alone, so I went and got my.
Oh, wearing a hat?
This was $7 on the internet.
There's a pub hat. Yeah, I got one of those. That's my favorite,
like
the pub
that.
hat.
I
Gotcha.
have one very similar. So
That's
this
true.
is, as you see, is this part of the sky near Hercules, the start of summer constellations. This up here, this red dot, is the asteroid Pallas, #2 Pallas. It's the second asteroid discovered. I notice in the articles and magazines that they are now referring to Ceres, the first one, which is spherical, as a dwarf planet and not an asteroid. Pallas is the first one since it's not spherical, as spherical as Ceres, but it's close. To refer to it as still as an asteroid. So it's right up there later in the evening.
We're talking hundreds of miles diameter or radius.
This is this
Yes.
is a picture of Pallas.
Oh, that's the guy named Pallas.
And this is Olbers.
Olbers.
Oh, that's Old Bears. I'm sorry.
Olbers. He discovered Pallas and Vesta.
Really?
So-
And so we name a comet after him.
I don't think they named a comet. I mean, yeah, they named a comet after him, but I don't think they named an asteroid after them.
It's because he found the comet that his name is on it.
Yeah.
But the asteroids traditionally have mythological names, but of course they ran out of them, so now they're all kinds of stuff.
Well, why do they call that a broken up comet that fell over Spain and Portugal? How would they know that? Have we been watching something else?
Okay, so there are regular meteor showers that are caused by comets and in the cometary orbit that we pass through, and it may be pieces of that.
Okay, so the comet's long gone. It's the trail stuff.
Yeah,
We'll call it trail mix.
yes.
That we pass
And
through.
the comet may or may not be long gone, but this is a chunk.
Got it. All right. We don't have Ceres picture though. It's a definite sphere.
Oh, it is. Yes.
Yeah, it's close to a sphere.
And Jerry, you said it's classified as a dwarf planet.
No, I've seen Ceres referred to as a dwarf planet. Pallas is close to a sphere, but I still see it referred to as an asteroid. They're all the names are artificial cutoffs of what's a continuous distribution of shapes and weights and sizes. So it doesn't really make much difference. It's just a big round rock, and they're all smaller rocks up there.
Minor solar system bodies.
Right. I did read that they developed that it was someone is reporting or published a paper using an AI algorithm to go over old photographs, and they've discovered 25,000 undiscovered previous comets in old photographs.
Well, those were asteroids, and it was a
right.
citizen science project too.
Asteroids, excuse me.
Yeah.
They were there all along. We just didn't see them.
That's right. They
Didn't recognize them. Yeah.
Right.
Amazing.
AI has done some very, very nice things in our hobby. One is, as you just heard, identifying new asteroids. But 2 algorithms have been developed for image processing by Russ Kroman that just are fantastic in clarifying, sharpening, and reducing noise in astro imaging. It's revolutionary stuff.
Well, can I present my little question, my stupid, silly question? I've talked about this before. The asteroids that are solid, or meteorites like Chuck has, that can't be made just by pieces floating together and clumping together like they say. Some asteroids are made like that. They're just full of debris, but you'll never get them to clump that hard together. They got to be broken up big ones, don't they? The ones that are solid.
No.
No,
that's the stuff clumps together and it clumps together and clumps together until it's big enough that the gravitational contraction energy generates heat and radioactive elements in them generate heat and they melt and differentiate. And that's where you get the nickel iron solid stuff in the core. And you get rocky solid stuff out in the mantle and the crust eventually when it all cools down. And then they get broken apart in a collision. But the rubble pile asteroids are ones where you just don't have enough material there so that the gravity is really light, and they're just fluff balls.
But they're rock. They're little pebbles, aren't they?
Yeah.
We stirred some of them up.
And those chondritic meteorites are the ones that never differentiated. So they come from really, really small bodies.
But you got to know that there was a time in the early part of the solar system when there were rocks falling on the moon, falling on the Earth, and I'm sure they collided out in what became our cloud, our asteroid cloud, and
There are
broke
two
up big
periods
bodies.
called major. There are two periods called major bombardment periods early in the
Right.
history of our solar system.
Yes, and those pieces are like, that's why I have a chunk of nickel iron, because that body that had to be over 100 miles across got broken apart in a collision.
Well, that's what I'm saying. That the little ones that are solid have to be from big ones.
No, they don't have to be. They can be so small that they never differentiated.
Really?
Carbonaceous chondrites, chondritic meteorites.
Okay, I didn't know that.
There's a whole spectrum of dust on up to boulders on up to planetesimals.
And they can come together and just that small become something that hard that you tell them it's older than dirt and it'll make your feet like a duck.
Yep.
Drop it.
Ouch.
Wow.
But not in the case of the nickel irons. The nickel irons have to be in a body that melts and differentiates.
For those of you who don't know what I said, to feet like a duck, you have to hear his spiel at the star parties, and you'll know what I'm
That
talking
one right over his head.
about. Yeah, right. All right. What is this we're looking at, Jerry?
This
M13.
is go ahead.
Rotor.
Go.
They're not binary, but what are they called? Road star.
Oh, this is M13. This is the globular cluster.
Oh,
Yeah.
okay. Got it. M13.
Please.
And you can see a feature that is apparent to the naked to the eye in a telescope. And that is these three veins called the propeller.
Mhm.
Really?
Yeah, see the arrows point in at the three things, and there's sort of dark lanes here. You can
Mhm.
see them okay here too. So this is mimicking a telescopic view visually, but it's obviously a photograph. But it's not.
Jerry, I really learned something when you sent this, because I always look for stars that look like a propeller and not the dark lanes. So yeah, next time I check this out, I'm really going to look for that.
Oh yeah, I've
looking
seen
for
it a number of times.
Yeah, I was looking for the wrong thing.
Well, what's the bright spot in the lower left of each of those circles?
The nucleus.
Yeah, the core of the
Yep.
cluster.
It's not a black hole.
No. Well, we don't know that for
Yeah.
M13, but some globulars have them.
Okay. Okay. So your three-pronged propeller doesn't necessarily go across that center, that bright spot, does it?
No,
No, it's offset.
yeah. There's
Okay.
the
It's just
center,
kind of a
there's the
random
center of the propeller.
alignment.
It's going to be interesting. I'm going to look for that. I was already looking for stars.
Hmm.
And this will be a showpiece at our summer observations.
Oh yeah.
Yeah,
Oh, yeah.
it's an easy object.
We ever get
Easy
rid
to
of the
find,
clouds.
easy to focus on.
Yeah.
All right.
Okay. Moving right along. This is going to Ceres,
Mhm.
which is now, this is the morning sky.
Mhm.
This is in the southeast. This is Sagittarius, which will be in the evening sky in about 2 or 3 months,
Mhm.
July and August. And this bright red spot here is the first and brightest asteroid discovered, the asteroid Ceres.
Oh, okay.
So the way that you spot an asteroid is you look at it and you make a quick sketch or a mental, you memorize the pattern of everything, and you come back a day later and see what moved. That's the only way you can tell it. You can't, a no scope from on Earth will resolve these asteroids into bodies, extended objects. They'll always.
I always wondered that.
Now, when these were first discovered, Ceres, Pallas, Juno, Vesta, they were considered planets.
Yeah.
Mhm.
And it wasn't until photography came along and they started to find thousands of them that they said, yeah, these things are like rats. We got to demote them. And they called them minor planets or asteroids. And asteroids was actually coined by Herschel. He said they look like stars. They're stellar appearance.
William,
So-
William or John?
William.
Okay.
So they're not very bright either. They're usually just beyond visual magnitude, beyond 6.
But can I ask my silly question about our big black hole that's called Sagittarius A? Is it in the center of the Milky Way on the right side that seems to be beside Sagittarius, or it's in that constellation?
It's right
in
off the
here.
it's right off the point of the teapot. A little lower, Jerry, a little lower. Yeah, like right off the point of the arrow there. Yeah.
Yeah.
Okay. So that's all part of the Sagittarius house in the zodiac, I take it.
Yes, Sagittarius A star.
Yeah.
And Sagittarius is always across the big Milky Way, angled across the sky.
It looks like the steam coming out of the teapot asterism.
It does.
Well, I'm amazed they consider that black hole a star. I guess it
They
is. It's a
don't. They
collapsed star.
don't. It's a star is just a way of designating it, like an asterisk.
Yeah, it's not a star, it's an asterisk. It's A star asterisk.
Really? They call it
Like if they have a
Sagittarius
footnote.
A.
Yeah, they call it Sagittarius A star. Sagittarius A was a radio source, and they didn't know what was causing it. And when they figured out it was a black hole, they designate the black hole itself as A star.
And it
Reading
doesn't have a big accretion disk because they can
Yes,
see
it
stars
does.
going around
Yeah,
it.
the
Does
whole
it have a,
Milky Way.
oh,
Well, in a way it is, yeah.
got it.
Now this
Fascinating
is
stuff, gentlemen.
as the Baron announced earlier, this is a double star. It's at the center of the bullseye and it's not resolved in this chart. But it is
Core Corolli?
there are 15 and 17 Canis Venaticorum, which means they're in Canis Venatici. And they're a 6 magnitude pair. They're not terribly bright. They're very close together.
I see.
And
Five-
Corcoroli is the bright thing right to the upper kind of 1 o'clock position of the bullseye.
Oh,
this?
okay. Okay.
That
Yeah.
And they don't orbit each other.
no,
That's
they
correct.
don't. They're one is about what is it? One's 200 light years away, and the other one is 1,100 light years away.
Yeah, Core Corolli is
So they're just a
260.
chance superposition of 2 stars that are about the same magnitude and would lead you visually to think they might be a binary star, but they're not.
Yeah.
Yeah, got it.
So it's just
And so-
Jerry, Core Corolli, by the way, where your little hand is. Yeah, that's
Yeah.
260 light years away. And I tell people that the light started when Mozart was writing his first symphonies.
All right.
Okay.
Is
And
it
that's a
possible?
beautiful binary.
Oh, it's gorgeous. Yeah.
Which one is a binary?
It's in
bright
the
one.
center of this red
It's the
circle.
bright one above the target.
Oh, okay.
Oh,
So
this
one of the single stars is actually 2, but the other one that makes it look like there's 2 stars is way beyond it.
No, no, Ron.
No.
The one in the bullseye is 2 single stars, and that's
Right.
all that's there.
Okay,
And
it's
they
not
are
part
just
of
a
the double.
chance alignment. The bright one is Corcoroli, and that's a binary system.
Okay.
Yeah, Alberio, they used to think was a binary, but now they have determined that they are not.
Well, that's
Or-
still in
or-
flux. I don't know
So
if they've
this is-
decided that yet.
Just to recap, this is a double star, but not a binary.
Yeah.
And this is a binary.
Yes.
Wow.
Okay. Now, this just represents the rising full moon, which happens Thursday morning at 7 o'clock here. The rising full moon is the flower.
Wait, rising full moon should be in the evening.
Yeah.
Yeah, this is, oh, did I say morning?
Yeah.
Yep.
It,
It goes down like the sun. in
yes,
the-
rising full moon is in the evening.
Looks like it's at the head of the scorpion, huh?
Yeah.
So it's going to be a low sky thing as it goes during the night.
Now, this picture was taken a couple of years ago, and it
Okay.
also has Mars in the picture too.
Mm-hmm.
It was just a nice picture.
Yeah.
And that tree reminds me of star parties. They're all around us.
Yeah.
The sun came out, by the way, guys.
Really?
Yeah, here it is.
Okay.
Really nice. Just put
Yeah,
in some
and if
tomatoes.
you're on the East Coast, I think the moon is actually going to occult Antares
Oh, wow.
later this month, I guess.
Yeah. just like last summer, Chuck.
Yeah.
That might have been when you guys went to Ireland or something.
That was back in August.
Yeah.
Well,
August.
an occultation using the moon doesn't take long. It's not a real short one, is it? It'll take quite a while to pass behind.
It depends. The ones that are really cool skim right along the edge of the moon, and you get
Yeah.
mountains and valleys, make it blink on and off.
Oh, is that right?
One of the first things I ever saw when I got into this hobby in the 60s was the occultation of Saturn.
Mm.
That was very dramatic.
Mm-hmm.
This one, as Chuck mentioned, in the eastern part of the U.S., but not in Western California,
Okay.
the moon will occult Antares, and in Northern Europe, in Britain, it will occult the star cluster. I think it's M3 or M5.
Okay.
Have to be M5.
Yeah.
Yeah.
Okay.
Good.
But none of those are visible. The timing's wrong for us here, and the positioning is wrong.
Mm-hmm.
So we're going to pass on that this year. This is another, the reason we're looking at stars and bright things is because the moon is so full, it fills the sky with scattered light, and the sky is nowhere near as dark as this planetarium presentation shows.
This is Tim's favorite.
Yeah, this is
Oh,
Herschel's
yeah.
Comet star.
Yeah. Musefi.
Makes me wonder if anybody saw anything on Saturday night for International Astronomy Day.
Nope.
No.
We canceled it.
And hey, Chuck, how many people we get during the day?
204.
Not bad. Yeah, Maureen
It's a
asked me.
slight undercount because at one point the counter went off to have lunch and the counter to somebody else, but it's in that neighborhood.
What a group of tireless volunteers willing to go out with their scopes and set up in mass and no sky to see.
Anyway, this one is in Cephas, the king. The structure here is, as I visualize it, not every planetarium software does it this way, but it's like a house tipped on its side. And from the peak right through the bottom of the floor, there's a whole bunch of other structure in here. But this, you go past that, and that's the Garnet star. It's a reddish star, and it is red because, and this is a segue into the next topic, because of the interstellar medium is dense here, and the light coming through, only the red light makes it through from the star.
Star stuff.
The red star.
Plus, it's also a red supergiant.
Right. It's carbon star.
Yeah. It is one of the largest and most luminous stars in the sky. It's
Is
2,000.
it also known as
light-years
Herschel's
away.
Garnet?
Say again, Bruce?
Is that also known as Herschel's Garnet?
Yes.
Yeah.
Another name is Arrakis.
Arrakis.
Yeah,
Is that from Dune?
I can't remember. I read where it came from because there is another Arrakis, but it does have a separate name as Arrakis. Erakis, I think it is.
Yeah, that's the famous home of the main character in the series Dune, science fiction.
Yeah, in that it's ARRAKIS.
Yeah, Arrakis.
But didn't you say we were going to talk about interstellar medium here?
Yeah, I was telling you that's one of the reasons it's so red is because of the interstellar medium, which does not pass, which is better at passing red light than blue light. It scatters the blue light. So as the Baron indicated earlier, Carl Sagan once famously said, "We are star stuff." But what exactly is that stuff? It's the area, it's the stuff between stars, between solar systems. It's inside the galaxy. It's interstellar, not intergalactic. It's where stars are born and where stars recycle their atoms when they die.
Atoms.
It's made up 98% of the mass of the interstellar medium is hydrogen and helium, and the remaining 2% are heavier elements like carbon, oxygen, and other elements, which, as probably know, astronomers refer to as metals, most of which are not actual metals. From my field of condensed matter physics, metals are things that can conduct electricity, and their conduction band is half full of electrons. Some things called insulators are completely full and they don't conduct electricity, but those are in astronomy are also called metals. So go figure.
Do I understand water is not a conductor or is a conductor? I think
Distilled water is an insulator, but it doesn't take much, things to what am I looking for? Salts that are in it to make it conductive.
so it's the minerals and stuff that conduct the electricity that's in water.
Right. They provide the ions
Water
that
produces ions. When things get in it, they dissolve in water. They become ionic, and that conducts. Water is a polar molecule. It will align with an externally applied electric field, but it does not conduct it.
it's also got a very high dielectric constant. It's like 80.
So rainwater would not be it'd be pretty safe. You were in a rainy situation.
No, our rainwater is acidic. It comes from all the pollutants we put into the air.
Oh, so there's stuff in it. Okay, got
And
it.
once it hits the ground, don't count on it.
Down in I was born and raised in Los Angeles, and in the 50s, on a TV show one night on a news channel, they showed a woman who rubbed her finger along the back of her calf where she was wearing nylon stockings, and the nylon stockings came off as a goo off of her leg.
Oh God!
The smog and the water, the moisture in the air had combined to produce sulfuric acid, and they had dissolved her nylons.
Oh boy!
Oh my God!
So even fog is not safe.
And our cities dump a lot of stuff in our water, don't they? Fluoride.
Well, that's in the water, yes, but up here in Goleta, we depend mostly on well water, and that is loaded with hydrogen sulfide and sulfur dioxide. Water wells up here frequently smell like rotten eggs, and some of them
we have the Cater treatment
cannot
plant
purify them to add them to the water supply.
That's why we have the Cater treatment plant up in the foothills.
Yeah,
They get rid of those things.
For Santa Barbara, yeah.
yeah.
Why did Flint, Michigan get so much lead in theirs?
Lead pipes.
Pipes.
Is that what it was? Okay, that's man-made then. Unless there happens to be a strain of lead in the earth load around you.
Well, that's what they think was caused the demise of the Roman Empire, because they used lead pipes to pipe their water around.
Well, all this star stuff you're talking about, it's anything above hydrogen. It had to be in a star earlier. Hydrogen could just be out there.
No, hydrogen could have come. Hydrogen was the most that there was at the very beginning when the Big Bang came. So the hydrogen doesn't have to be anywhere to become hydrogen. It's hydrogen from the get-go.
And there was a little bit of lithium and beryllium after the Big Bang too,
and helium.
Yeah.
So this is a look at the dust that's in our galaxy. This is the Milky Way spread out. The dark stuff here, this region here is called the Great Rift. It was believed that this was missing stars. Turns out it's not missing stars. It's star clouds like this and other places, but it's just got so much interstellar dust between us and them that we can't see through it.
Yeah, Jerry, that's a nice shot. And that feature right in the middle is often called the pipe. I mean, you can see the smoke coming out of the pipe. You see the pipe?
Right there.
Yeah, that's the smoke. Yeah. That's the smoke. There's the pipe.
Yeah.
And in Australia, that's an emu.
Emu.
Right.
I can see that.
Well, are those dark patches nebulae?
Yeah, they're dark.
They're dark nebula.
They're dark, yeah.
Okay, so if a spaceship rocketed through them, would it just be obliterated, or would it be just?
It depends on how fast it's going. If you were traveling at one of these mythical with a hyperdrive, or what do they call them, a warp drive, right? Traveling at half the speed of light, you would face a lot of erosion and paint peeling problems.
Yeah.
Yeah, and Einstein would pull you over for speeding.
Yeah. No, I was going half the speed of light.
Yeah. But Ron, there's some of this stuff is charged particles.
Yeah.
And one idea for a spacecraft where you don't have to carry a lot of fuel with you is to generate a big magnetic cone basically in front of you that would suck in stuff, anything that had a charge, and then you could use it as fuel. So hydrogen atoms, protons, and stuff like that. It's called a Broussard ramjet. And so you could travel through these things. These kind of things would provide you with a lot of fuel.
Yeah, just analogous to a jet engine going through air.
Mm-hmm.
I believe they call that force fields in the sci-fi movies.
Yes.
A force field.
If you want to feel a real force field, just push your fingertip against the wall. That is one force field pushing against another force field.
Right.
Because
Well, what would you define radiation as? Is that just the same stuff, only moving really fast?
No. A radiation is anything moving. Any small particle, an electron, a photon, a proton, a neutron, anything like that that's moving by itself is a radiation. You can also have nuclei, ionized ions that are also radiation. Radiation is a very benign word, but in the colloquial jargon, it's taken over a very sinister meaning.
Sure it has, and it's got to be protective of our astronauts going to Mars. One way was to put water in the shield in the curve around the ship they're in.
Yeah,
Yep.
put water in the. That's what the Starship, Elon Musk's Starship is going to do. They're going to put water in the double outer hull around the ship, both for human consumption and recycling. They're not going to get rid of it, but it protects against radiation in the long journey.
Oh, interesting.
They have that on this. I think they have the same thing on the ISS. They have a safe room, which is extra shielded, and I believe it's water in the walls.
I think they also use some sort of plastic substance.
Yes, I don't recall them having to lift tons of lead up there.
Yeah.
What is the force called that for some reason in my old age, I know the word, but it won't come to me, that pushes you against the edge of a rotating cylinder? What is that called? Force?
Centrifugal force.
Centrifugal.
Actually, it's centripetal force.
Yeah.
Could you classify that as another force beyond gravity, magnetism?
No, it's just a frame force.
It's
just because the moving frame.
Really? So it's a force, but it's not gravity, and it's not electromagnetism.
Ron, they call it a fictional force, I think.
Yes.
But it is a force. It forces you against the wall.
I like
Tom's
the
walls are forcing you. You aren't forcing
That's
the
right.
walls.
Good job.
Okay, gotcha.
Once inertia, you've got inertia. Once, if you're started in motion in a straight line, you just maintain that motion unless you bump into something. And it's the fact that you're in a circle and it's continuously changing you. You're not going in a straight line, and that takes a force to move you.
Right.
But only if you're in that frame and moving with the frame. That's why a frame force is the best way to say it, I think.
Yeah.
Hey, can I ask you a question, Jerry, on this image?
Coriolis acceleration is the same sort of thing.
Yes.
Oh, the thing that gives us hurricanes.
Yeah, you're confined to a spherical shell while it's rotating.
Tim, ask your question.
Yeah, in this image, you might have covered it, but why is the in the middle? Why is it brighter there where the pipe is? Why are we looking towards the
central bulge? It's a bar, isn't it?
Yeah, but that's where there's more or less interstellar medium blocking the light.
The interstellar dust here tends to cling to the plane of the galaxy.
Okay.
It's up here too, but it's much less dense. So you can see there's faint dark nodules up here.
So we're looking in there towards the core?
Yes.
Yeah, we're out here. This is an actual photograph or a series of photographs to make a panorama. You can see it was badly stitched together here. You can see a line on there.
Oh, okay.
We are, as science fiction refers to it, the sun, our solar system is a rim world. We're near the rim of the galaxy. So most of the galaxy is interior to us. And so here we're looking toward the center of our galaxy. It looks just like other galaxies that we see, like the, what is it, the Pencil Galaxy or the
needle.
Yeah.
Yeah, 4565.
Yeah. So we see a lot of these around there, and we're one too. This is us looking at our own galaxy.
So this would be more like in the summer when we tell people at the spout.
Oh yeah, Tim. Yeah,
Yeah,
you're
you're
looking
looking-
near the tail of the scorpion right here, you know?
Okay,
This-
okay.
Yeah.
And then
So-
as you swing up over the arc and you go up into Cygnus, now you're looking out.
Yes.
Yes.
Okay,
Especially out toward Perseus and Cassiopeia is when you're really looking out.
And
okay,
Virgo,
okay.
Yeah.
the
Good
Virgo
deal.
cluster,
Okay.
Leo, those things, that's looking up the North Pole.
Yeah. Virgo's looking perpendicular.
Mhm.
Yeah.
Okay.
Well, science knows it's a bar, right? We have a barred galaxy. Do they know which way we're looking at it? Is it lengthwise, edge on?
They've only recently decided that it's a barred spiral, and there's no good photograph to illustrate that. It's made by plotting distances to known features on a graph.
And I don't know that I've ever seen anything hinting at what its actual
Yeah, orientation.
alignment is relative to us. Yeah.
Mhm.
Wow. All that
So
dust
this
you're
interstellar
looking at-
medium is the leftover crap that stars throw out when they die, waiting to make other things. And they need some kind of disruption to start the process, some kind of a shock wave or compression to push this stuff. It's uniformly spread out when the stars explode, but it needs something. This is a bow shock wave from the star Zeta Ophiuchi, taken with this Spitzer Space Telescope. And this is the kind of shock wave that causes the stuff to clump up. And it gives gravity an edge because while it's real dense like this, it will start forming other dense particles also.
Ladies,
So-
classification, right?
Oops. Now this one, we're going to look at an update to stellar classification on this topic. This is Annie Jump Cannon in the 1880s. Wilhelmina Fleming and Annie Jump Cannon. This is Annie. Worked out that you could tell the star's surface temperature by its color. And they listed them using letters from A to O with all letters of the alphabet. They eventually streamlined it by throwing out just throwing out most of the small classifications after they had spectral data. And they ended up with types A, B, F, G, K, M, and O. They relisted them in order of temperature and came up with, they were the ones that she was one that made the mnemonic, Oh, be a fine girl, kiss me, which is what I learned in the 9th grade astronomy class. Although that's been updated nowadays to, oh brother, astronomy frequently gives killer midterms, and oh boy, an F grade kills me. So other things that students have learned over the year. Now this worked fine. Her classification system was unaltered up until 1988, when they started discovering brown dwarfs. And we're going to go quickly through this.
Brown dwarfs are us.
So they added to it, types. Let's see, where is that?
L, T, and M or something.
Yeah, LT and Y.
And there is some fusion going on these little suckers, aren't there?
There is
Briefly.
some, yeah, first of all, they're very, very hard to spot. They're very cold, and they don't put out a lot of visible light. With the James Webb Space Telescope up there, we're now spotting these things. They're down, the temperatures. For example, here's our sun at 5,800 degrees Kelvin. There's Gliese 229A, or Gliese, not too sure how to pronounce that.
I guess
And then there's other objects now that we've seen and measured their temperature by their infrared signature, all the way down to Jupiter, which is also an infrared source. These are due largely to gravitational collapse. And that's why they get hot, and then it takes a long time for those that heat to dissipate out into space, but eventually they will cool off. Now, so the definition of a star is that it has continuous fusion of something, and hydrogen is the easiest thing to fuel or to fuse. So it has to have sustainable fusion of hydrogen in order to be classified as a star. A lot of these bodies are fusing things, but they're not fusing hydrogen in a sustainable way. They have just made it high enough they can do brief fusion of helium and hydrogen, but it's not sustained. There's not high enough temperature. So they get hot that way, but it's mostly heat from gravitational collapse. And that's where you get down below 1,000 degrees temperature for these things. They will just simply coast until they become cold bodies. Jupiter is included in those. Jupiter is not a brown dwarf. The coldest brown dwarf is this WISE 1828.
Well, now, Jerry, there's a planet right next to us, our twin, that's much smaller than these brown dwarfs, which is hot as hell, but that's all on the surface, isn't it? Venus.
That's a different, no, but yes, but those are not infrared stars. They're hotter than hell because they're white dwarfs. They also are hot because of gravitational collapse, and they will cool off. And at some point, those white dwarfs will cool down to become a brown dwarf on their way to becoming a non-anything. They'll just be a dark object.
Well, I thought Jupiter radiated more heat than it receives from the sun.
That's right. It's an infrared source, and it's from gravitational collapse. It's still working.
Oh, okay.
And from radioactive elements that are in it.
In the core.
Yeah.
And that's why little Io goes through wrenching, terrible blasts of.
Io is not a brown dwarf. Io is being continually kneaded with a K,
Right.
like by its parent Jupiter, which is doing tidal distortion of the core of the planet. And so that's frictional heat that's causing all that molten stuff to work to the surface. The thing is, Io is very close to its Roche limit around Jupiter, which is where it gets close enough that tidal forces will pull it apart. Here, the tidal forces are just wreaking havoc in the core.
Well, does science ever reach a point where we don't know what to call this binary? It's either a planet that's super large orbiting a regular star, and therefore it's a brown dwarf.
Well, that's more popular science, the trying to name it. Most scientists don't really care what it's called. They want to know about the properties of it and its performance. So they want to know the temperatures, the mass, its luminosity, for example, things like that. Classification is sort of an official thing. I forget the name of the astronomical body. What is it? The
International Astronomical Union.
Thank you. They decide on the names for things, but most people don't hang their hat on a name. Neil deGrasse Tyson is still telling everybody to get over it for Pluto being demoted, but it's not really important. Pluto is still Pluto. It's still there. It's still whatever it is.
But anything goes in the universe because that Gliese 229a, that large one on the picture here, could be orbited by some of these on the right, and therefore it becomes its own stellar system. But it could orbit
anything can orbit anything else.
Okay, it's
just if they're close enough and if they're going with the right speeds.
Okay.
When scientists don't know something, they tend to give it nice names like dark energy and dark matter.
Yeah, right.
Just euphemisms for things they don't know. By the way, I read an article, I don't know exactly how accurate it is, but there's apparently a competitor to a black hole that is similar to a black hole, but the math of this other object, well, we'll talk about that another day. It's too complicated. I just read an article once.
Well, okay, headline it for next week. My last stupid question is, if you had regular planets orbiting a large brown dwarf, there'd be no Goldilocks zone, would there?
It depends how hot the brown dwarf is. It could be very, very close to the brown dwarf.
Yeah.
Okay.
I thought they discovered planetary systems that were that way.
They've discovered all sorts of odd things, bodies orbiting each other. They found large Jupiter planets in pairs in the Orion galaxy, orbiting
Orion Nebula.
Yeah. Yeah.
But those 5 balls on the screen on the lower part are all brown dwarfs. The yellow one
No,
that we see
No,
partial.
Gliese 229A is a red dwarf star.
Oh, it is a red dwarf. It's
Yeah.
like Proxima Centauri, right?
Yes, yes.
Which is a little suckers with its own zone around a Goldilocks. Well, gentlemen, we're going to do it again next week. If you'll join us on screen, let's do it here for episode number 170. We got a lot of cancellations of our SBAU outreach due to May Gray, and June Groom is right around the corner. It's going to be even worse. Watch your email inboxes, everybody, for notices coming from either Andy Allen, our secretary, or our outreach guy, Chuck. Do plan to attend our second Friday of June general meeting, will you? On the 14th, when our museum's Astro programs manager, John Winkowski, is going to speak on the moons of the solar system. And our star party will be a week earlier than that on the night of the 8th. And in the meantime, I guess there's a professor getting married. We're going to have a party on the 31st out at Westmont. Talk about that too. Take care of yourselves and your wives, and don't let the overcast get you down. We're going to win.
Thank you, guys.